Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Glucose is an aldose, aldehyde sugar, while fructose is a ketose, ketone sugar. A reagent that distinguishes between them must react with one but not the other. Moving on to the next step. Bromine water is a mild oxidizing agent that specifically oxidizes aldehydes but does not oxidize ketones under mild conditions. Glucose, aldehyde group, decolorizes bromine water, whereas fructose, ketone group, does not decolorize it. Therefore, bromine water can distinguish glucose from fructose. Moving on to the next step. Tollens reagent oxidize both aldehydes and alpha-hydroxyketones. Fructose, despite being a ketose, gives a positive Tollens test because it undergoes tautomerization through enediol intermediate in the basic conditions of Tollens reagent, converting to an aldehyde form. Both glucose and fructose give a positive silver mirror test. Therefore, Tollens reagent cannot distinguish between glucose and fructose. And for the final step, Schiff's reagent tests for free aldehydes. However, under the acidic conditions of Schiff's test, fructose can also tautomerase or enolize and give a positive result. In practice, both glucose and fructose give a positive Schiff's test, so it cannot reliably distinguish them. Therefore, Schiff's reagent cannot distinguish between glucose and fructose. Conclusion: only bromine water, reagent I, can selectively distinguish glucose, aldehyde, from fructose, ketone, because it oxidizes aldehydes but not ketones under mild conditions, and the basic alkaline conditions required by Tollens and Schiff's reagents cause fructose to tautomerase and also give positive results. Therefore, the correct answer is C. Therefore, the correct answer is option C.